What's up, advanced math fans? A little more statistics today. So we're going to continue our discussion about stats, but what I want to talk about today is how we measure how spread out the data is. And so we've already talked about mean, median, and mode, and talked about measures of the center of data. But now we're going to talk about a measure of dispersion. It's called dispersed, spread out, in other words. And so the two big ones we're going to learn about today are variance and standard deviation. Now, to be completely honest with you, standard deviation is the most important. We're going to see that variance is kind of a step along the way to get standard deviation. It's not reported near as often. Standard deviation is the one that is most of the time reported in a study. And so we're going to see if we can find out what these things are and how to figure them out. So variance is you take each entry minus the mean. Remember, we learned that x bar on the top is the mean, or the average. So you take every entry minus the mean squared. And so if you notice, we have a whole bunch of quantities where we do this. Each entry minus the mean, that quantity squared. Add all those answers together and divide it by n. And remember, n stands for however many pieces of data we have. So if we had 50 pieces of data, we'd have to do this 50 times and divide by 50. And then standard deviation is signified by this little cursive O looking thing. It's actually a lowercase Greek sigma is what it is. Kind of looks like a cursive O. And this is the typical distance of an entry from the mean. This is the more important one. So this set tells us, on average, how far is an entry away from the mean. It's basically what standard deviation is telling us. And so the way we find standard deviation, well, if we have the variance, standard deviation is really easy. It's just the square root of the variance, and that's it. Now, there is an alternate formula for finding standard deviation. It's right here. It doesn't matter which way you do this. You could use that and then take the square root of it, or you could use this to get standard deviation. They both give you the same answer. So those are the big new things today, variance and standard deviation, and how we find them. Let's see if we can put this to use with a set of data now. And so I have this set of numbers. We're going to try to find the variance and standard deviation of this set. 9, 12, 14, and 5 are our numbers we're going to use. And so we're going to add these together. First thing we're going to do is find the average. Now, the way we find the average of a set of numbers is we add them together and divide by however many data entries we have. So in this case, we need to add all those together divided by 4, because we have 4 data entries. And so, let's see what we got here. We've got 14 and 12, and then another 9 and 4, so that's 26, and then another 14, so we've got 40 here. And then divide it by 4 means our mean, or x bar, is 10. So our mean on this one is 10. Now let's see if we can find the variance. So to find the variance, I'm going to use this right here. Remember, x sub 1, x sub 2, all the way up to x sub n just represent our data entries. And so we're going to do something like this. We've got 9 minus 10, that quantity squared, plus 12 minus 10, that quantity squared, plus 14 minus 10, that quantity squared, plus 5 minus 10, that quantity squared. And then we want to divide all that by n, which in this case we've got 4 numbers, so that's 4. Alright, so let's figure out what all these are. Now you'll notice that some of these answers come out positive in the parentheses, some of them come out negative. In the end, they will all be positive, because you notice every single one of these quantities gets squared. Since they're all squared, and that's actually kind of the purpose of this, because if we're just wanting to know how spread out the data is, we're not really worried about is it above or is it below the mean. We're worried about how spread out it is. And so that's why this formula is the way it is. It basically makes the negatives not matter when we square them. And so 9 minus 10 gives us negative 1. But when we square that, and I'm going to go ahead and do the addition, or I'm going to do the subtraction and then the quantity and square it here. And so 9 minus 10 is negative 1, squared is 1. And then 12 minus 10, we get 2, and 2 squared is 4. And then 14 minus 10, we get 4, and 4 squared is 16. And then 5 minus 10 is negative 5, and negative 5, when we square it, we get positive 25. And then remember, it's all those answers divided by n. And so let's see what we've got here. We've got 20, and then we've got 1. So we've got 21 plus another 25. And so that gives us 46 over 4, which if I divide that out, that gives me my variance is 11.5. All right, so there's how we find the variance. Now for standard deviation, because that was the second part of this, if we already have the variance, standard deviation is really easy. Standard deviation is the square root of the variance. Variance was 11.5, so I'm going to take the square root of 11.5. And this doesn't come out to a super nice number, but that's okay. A lot of times the standard deviation does not come out to a nice number. And so the standard deviation on this one is about 3.39 if I round it to a couple decimal places. Now if you wanted to, you could put all those numbers into this formula right here. So it would say something like 9 squared plus 12 squared plus 14 squared plus 5 squared. Get that answer, divide it by 4, and then minus 10 squared. Take the square root of that. That would be another perfectly acceptable way to do this and come up with the standard deviation. So that's how we find variance and standard deviation. So remember what standard deviation is. It's typical distance away from the mean. So the typical distance away from the mean in this set of numbers is around 3.39. Now, think about how difficult this would be if we had a large set of data. I made this 4 numbers on purpose because I didn't want to do this with like 100 numbers. Now, these days, nobody does these computations by hand like this. There's programs that do this, and there's statistical programs or calculators. And I'm going to try to show you guys how to do this. Your graphing calculator actually has a program built in to do this. So I won't ever be asking you to do this with a really large set of numbers and doing this longhand like this, because really, why? I wanted to show you an example of it so I could see like kind of what the calculator is doing and what is happening with standard deviation and variance. But with large sets of numbers, we're going to be using technology to come up with variance and standard deviation instead. All right, so that should get us a good start on measures of dispersion, and hopefully get us an understanding of what that means. And then we'll have to use some of this stuff with mean and standard deviation when we start to talk about normal distributions coming up soon.